Hi everyone, we're the MobilePerimeter team. My name is Irina Khan and this is Joseph Azam, and we're both working towards our Master of Computer Engineering in the ECE department at U of T. Our specialist for this app was Professor Moshe Eisenman from the Department of Ophthalmology. We also worked with Ilona Wang, who originally created the original prototype as well as her thesis behind this project. So the overall goal for our app is to provide a mobile and affordable eye exam to test for contrast sensitivity useful in determining the progression of glaucoma. At a very high level, glaucoma is an eye disease that's characterized by pressure buildup in the eye. Determining or detecting the disease early, as well as being able to run constant tests to maintain it, to watch for its progression, is essential in reducing the risk of blindness in patients. So for our specific project goal, we focused on 3 specific objectives to enhance the existing app. So the first objective is to create voice guidance for head calibration, so the users don't have to focus on the screen and try and figure out how to move into position. In order to do that, we had to improve the head tracking algorithm for accuracy. And in order to make sure that they don't have to use a proprietary Bluetooth clicker, we created a universal input method, so they can use a selfie clicker or any other Bluetooth clicker. So those 3 objectives create a more intuitive and independent application, which we're going to show you in a minute. At a very high level, this is our block diagram. So it's color-coded based on the features that we've enhanced or features that we've created from scratch. In gray, we have the existing features of the app. So we have the main activity, so in blue, we have the features that we've enhanced, and in orange, we have the features that we've created as part of our project. So there's the main activity, which guides the overall flow of the application. We have a pose estimation module in the background, which uses a pattern to track the position of the user relative to the tablet. We have voice guidance module, which uses the positioning module to guide the user into position. We have the perimetry test module, which was the existing logic and math behind the stimulus intensity on screen to see whether the patient can actually see various strengths. And it uses the ambient light module to figure out the strength of stimulus on screen. We also have the database module in order to store the user test information in the background. We have the configuration module for just basic settings. And we have our newly added input capture module, which replaces the previous Bluetooth module in order to use a universal clicker. So now we're going to go through one quick usage of our app. So imagine Joseph has just gone to the doctor and he was diagnosed with early stage glaucoma. Joseph is given medication to make the condition better, but the doctor also recommends that Joseph tracks the condition by using the mobile app device, MobilePerimeter app to track his condition over time. So Joseph downloads the app from the App Store. He clicks on the print pattern button in order to get the pattern. Okay, he gets the pattern and prints it. He then goes to his nearest electronics store and picks up a Bluetooth clicker, so any universal clicker will do. He can use a selfie clicker or pretty much anything that's available in store. And on his way home, he stops by a dollar store and picks up a quick, cheap pair of plastic glasses and attaches the pattern to them. Joseph is now ready to take the test daily in the comfort of his home.
Use buttons to adjust the circle onto your eye.
So the app uses voice guidance to guide Joseph into the original position. So Joseph will position the circle over his eye, that's the initial calibration, to figure out the distance between his pupils. Once he's done that, he's going to click done.
Position yourself in the center of the screen, left and closer.
Now the app is going to guide him into position in order to get accurate results from the test. Okay, so now he's ready to start the test. He's going to use the Bluetooth clicker to begin the test. The test will show stimulus on screen of various intensities and various points of the screen, so we kind of limited it to only 3 points in order for the test to be quicker. As you can hear, there's also feedback that shows Joseph that the click has been registered. And the dots move across the screen to test the different positions, and they go in intensity, and he clicks every time he can see it. So in areas that he can't see, the intensity are going to register as him not being able to see. Now the test is almost done. It's our third and final point. So with the projection screen, it's a little hard to see the stimulus. Obviously, some of them are incredibly light. So now that the test is completed, there's a final screen that shows the results of the test. And Joseph's able, so all of those tests get recorded in the database. And Joseph is able, in his next appointment, to take this app to his doctor and go over his results. Okay, now Joseph's going to talk a little bit about the key learning.
Okay. So there are many challenges that come to when using a pre-existing app. So what our major key learning was we needed to set more attainable goals. And also, not knowing the complexity of the application, we did not allocate enough time for bug fixing and troubleshooting. In addition, we had to add some standards for our application. We have developed a few interesting features, however, not all of them were implemented in the final version of our app because they did not provide, for example, enough accuracy, like the voice command feature. So, for our future work, we do believe that our work did move the application forward. However, there's a lot of work that still needs to be done, and we would like to suggest first optimization. The application has already consumed a lot of resources on the device, and when we added the features like text-to-speech and the voice command, it became even more heavier on the device. So it needs to be optimized, but also we can just try it on a newer device that's a little bit faster. In addition, there's the voice command feature, which is in fact working. However, it does not provide good response time or accuracy for short words. And it needs more work, so eventually it can be implemented and replace any inputs devices like the Bluetooth clicker. And finally, we have the the Google Cardboard, which is a cheap virtual reality solution. It costs around $5. We have a headset over here that costs around $25. This is a more fancier version of it. And all you have to do is slide your device inside. It has two lenses, so it covers your entire field of view. And so we also made a proof of concept of our application. And so you're welcome to come and try it after the presentation ends. I would like to thank everyone for their time.
Hey, that's pretty neat.
It's very cool.
You came to work on the smaller screen and up close here. It doesn't need to, you don't need any head tracking for that.
Right.
Yeah, so that's kind of why it's a good idea to move forward, because you don't need the head tracking. Obviously, there's distortion because of the lenses, and you have to adjust it, but there's all kinds of APIs that come with it that let you do that.
Is that the Samsung thing?
No, this is just Google Cardboard. It works with
Google Card.
yeah.
Very fancy. A plastic Google Cardboard.
Yeah, it works with any Android device. So, do you want to try it?
Not right now. I've done that test too many times.
Okay, cool.
Hey, well done. It's nice to see the clean demo and it looked like it was working. And is it correct that there are lots of selfie clickers in the world and there's a standard interface that they're all going to have?
Yeah.
There are, yeah.
Oh, that's great. I didn't know that.
So this one, the one we were using for our demo, I don't know where it is. It's just a regular Bluetooth, just a regular Bluetooth clicker that you can pair with it, but all selfie clickers just use the same kind.
That's great.
So,
Well, then this is a tricky project to build on top of pre-existing code. I appreciate your.
That's
your
been a
comment.
challenge.
Absolutely.
so if you want to see something, this is the camera, and I can take it. So it's a selfie clicker.
Yeah.
Yeah.
Cool. Any comments, questions?